Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. This video demonstrates the premium configuration of VisualMILL 2016 being used to rough out a part from multiple sides using positional 5-axis setups. Without further delay, we invite you to sit back and enjoy the demonstration.
Where would you like to set the XYZ 0?
Let's get on this corner.
Corner of the plate?
On the center, it will be higher also.
Okay, so the center would be for X and Y. How about the Z? Do you want to put it to the top or at the bottom?
Yeah, to the top.
To the top. Okay, so what we'll do now is we'll define our stock and then go ahead and establish the center to it, right? So we could do a stock and we could do box stock. Are you going to be starting with a blank, or are you just looking to, profile around the trim on this part? So what is it that you're looking to graph?
What I'm trying to do is just the surfaces on the top. Let's say this is the mold.
Okay.
And we're gonna machine the mold, and then we're gonna trim it.
Okay. Okay. So basically, you're looking to machine or surface these surfaces in here, right? All of these surfaces. Okay, and then you're also looking to cut this trim around the part.
Yeah.
Over here.
Perforation from the top. Yeah.
Right, but we don't need to really mill these surfaces, right? This is just like a fixture to hold the part, right?
Yeah, that's what it is.
Okay, all right, perfect. So let's go ahead and create our stock. We'll select stock and then box stock. And when you select copy model box, this gives you the length, width, and the height. So the length is the distance along the X coordinate axis, which is about 13 inches. The width is distance along the Y coordinate axis, which is just over 25 inches. And the total height that you have is estimated to be about 16.8 inches. Now, would you going to be using a stock blank that's going to be slightly larger than this, or would it be square to this exact size? Can we go ahead and set the height to 17 inches?
Yeah.
Okay, so we'll set that right there. We'll pick OK. And there it is. The next step we want to do is align the stock. So we want to have the stock flush to the bottom of the part, because you have a nice planar surface at the bottom. So the bottom of the part is flush to the bottom of the stock. And then we want to have it centered in X and Y. So there's your stock. You can display the stock in here. Now I already selected the post to be a Thermwood 5-axis post processor, since I believe the machine that you're working with is the M67 91000 control.
Yeah.
So we have the post set up to 5-axis Thermwood. The next step is to set the origin. So we go to Align and click on Set World Coordinate System. And since you said you would want to put the 0 to the top face in the Z, and then the center in X and Y, we'll pick higher Z and then center. So your XYZ origin is now, when you take a look at this part from all the different views, like the 4 views, you can see it's set to the top in the Z, and if you look at it from the top view, it shows it's in the center in X and Y. Does that look good?
Yeah.
Okay. All right, perfect. Okay, so I'm going to go ahead and hide the grid in here. We can take a look at the part and the stock. Now the first step is you would want to basically rough this down in levels, right?
Yeah.
So you want to process a roughing toolpath. So this would be similar to how you do roughing in 3-axis. You would basically rough it down in levels in the Z-axis. So I can either create some tools, or I can go find a library of tools in here and go load a tool library in here. So let me go ahead and grab this library called Cutting Tools and click Open. So it looks like I only have 2 tools in here, so I'm going to go ahead and locate another library in here for the purpose of programming the toolpaths. I'm going to go find a library of tools. Okay, let me see where I got some tool libraries saved. So typically it would be under Program Data. It's here under MecSoft Corporation. You can go to VisualCam 2016. In the data folder, you can have your tools saved in here, or you may have it saved in a different location. You can go find the tools wherever you have it saved. So I'm going to go find the tools right in here. So there we have about 14 tools from the library. So the first step before programming this is I need to define my machine tool. So since this was going to be a 5-axis machine, I'm going to select under Machine Tool Setup, I'm going to pick Manual Definition and pick the number of axes to be 5. And the machine that you have has the 2 rotational axes on the spindle itself, where the part remains stationary and the tool can orient to different orientations to mill the part. So that would be a head-head configuration where the rotational axis is on the head. And the next step is to specify the primary axis, which is typically a Z-axis, and the secondary could be Y or X. I know for sure in the thermal machines, the secondary is the Y-axis. And for most 5-axis applications, you want to output all coordinates in the world coordinates, so you clear this checkbox. And then you would also specify your gauge length in here. So the gauge length is basically the distance from the pivoting point, pivoting point to the spindle face, and then we automatically add the tool length to it as you define the tools. So what you'd be entering in here is the distance from the pivot point to the spindle face or the collet face.
Okay.
So this could be
gauge length.
Yep. Could be like 6 inches or 5 inches or 7, depends on what it is on your machine tool. So you'd have to take the measurement, and that parameter remains constant for a given machine tool.
Okay.
So you would put that in here. So for now I'm just going to leave it as 0. Now we want to program some toolpaths, so we'll go over to 3-axis and we'll start the roughing process. We'll use horizontal roughing. So the selection of containment regions is used to limit or restrict toolpaths to specific areas. Since in this particular part we would like to rough out from the entire stock plan, I'm going to not specify or select any boundaries. Next we'll select a tool. Let's say we want to start with a 3/4 inch end mill. We can pick this tool. If you want to make edits to the tool, you can take a look at it. Let's say you want to change the height of the tool. You can always go back and change the properties in here. So I can change my tool length, and I can also change my shoulder length in here. So basically I can update all the parameters. Once you make the change, you can do a Save Edits to Tool. And also if you go over to the Feeds and Speeds tab, you can establish your feeds and speeds either using Load from File, or you can manually enter in your feeds and speeds based on the material you're cutting, the tool material. The system can give you recommendations on the feeds and speeds. Would you be able to tell us what type of material you're going to be working with typically?
Wood. Yeah.
Wood. Okay, so we'll select wood, and then if your tools are going to be carbide, you can specify the material as carbide, and this gives you a recommendation for your spindle speed and the cut feed rate. So if I change the spindle speed to 8,000 RPM, you'll
What
notice
about if I change the surface speed?
the surface speed, the feet per tube
400.
to 400?
Yeah, 400 inches per minute.
Okay, so if you're using a high-speed cutter, it automatically uses 400 feet per minute. Surface speed is in feet per minute.
Oh, okay.
Yeah, so you can change it, and this will be used for computation in here.
Oh, okay. All right.
So I'm going to Save Edits to Tool. There we go. When you go to Feeds and Speeds, you can see that all the feeds and speeds are being automatically loaded from the tool. The next step is to set your clearance height. It's set to automatic, so it will safely clear the stock and the part. And then you can go over to your cutting parameters, where you can specify the tolerances for roughing, your stock allowance, your step over. You can also specify your step down, how fine you want the cutter to step. You can specify engage and retract parameters. Also you can set your advanced cut parameters. And now in the cut levels, I could probably set it not to cut below a certain Z, right? Because you don't have a tool that's long enough that can be able to program all of these from one direction. So what I could do here is go to Cut Levels tab, and I can use a bottom containment, and I can pick a point how far down I want to cut in a Z. So I could say this is how far down I would like to go, and I can use these object snaps in here, the near object snap, to pick a point on the part. So you can see that now the plane automatically appears how far down you're trying to cut in a Z. right? If you feel that this is still too far going down in the Z, you can adjust it by using these spinner increments. You can set the Z containment levels right there, or you can even manually enter in. You can say you only want to go down up to 6 inches, and then you pick generate. So now the roughing toolpath is being computed. So once the toolpath is being computed, it'll automatically, the toolpath will be displayed in the viewport, and also it'll clear the flag on the operation in here. Any questions so far?
No, I mean, yeah, it's a good product. No, it's nice, yeah.
Okay, so when you have to rough it, you'd have to do indexed machining, so you rough it from multiple different orientations, and then you can go ahead and program a finishing toolpath. And there it is. There's your roughing path. The toolpath is generated. You can also view the toolpath in levels as you step through each level right there, and there it is. And if you want to go back in here, make any changes or edits, you can always make those changes on it. Now selecting save or save as will prompt you to save the file, and I'm going to just hit save in here to save the work. Now let's go run a verification. So let's go to the Simulate tab, and you can view the stock, then the toolpath, and then you hit the play button, and that gives you the cut material simulation. You can also speed it up by using the controls in here. You can also go ahead and change the speed parameters to how fast or how slow you want to simulate it. So there's your roughing simulation. Now if you want to skip through the simulation, you could always hit the pause button in here, and then click on simulate to end, and you'll notice that it's simulating through the end of the process. There it is. So it's roughing it out in levels. Now the next step you would want to do is you want to rough it from the sides, right?
Right.
So you could go ahead and click on setup, and you can add what is called a coordinate system setup. And now you can choose which side you would like to rough it from. If you want it to be normal to this particular side, you can click on select the surface, and I can just go pick the surface right in here. So the Z-axis will now be normal to the surface, and it uses the surface normals to orient it, and you can also reorient it by using these controls in here. So there you go. Your Z-axis is now set normal to the surface. Now rather than programming a roughing operation in here, I'm going to use a re-roughing operation, so it basically takes into account the in-process stock from the previous step. So we'll use a horizontal re-roughing, and now in here I'm going to specify the parameters. So similar to how we did for the roughing, you can select the tool, the feeds and speeds, your clearance. You can see now the clearance is in the same orientation as the coordinate system that you rotated from. And now you can specify your cutting parameters. You can set your step overs, and in the cut levels you can specify a containment, how far that you want it to cut. Then in here I can go ahead and select the containment, bottom containment. I can use the pick option in here to go ahead and specify an area to contain it. So I could say this is how far we would like to go, like to rough it. You can select that right there, and now you click generate. Now if you'd like to go further out all the way to the midpoint of the part, you can still do that by specifying the midpoint, or you can snap to the midpoint. So in this process it's going to create a horizontal re-roughing operation. So we might be able to just rough it from 3 sides, and that would work.
Yeah.
So it's computing the re-roughing toolpath in here, and there it is. You can see that it's re-roughing it, and it takes into account the stock that's being left from the previous step. So you can go to the Simulate tab in here and hit the play button, and there it is. Now if you want the re-roughing process to go to the midpoint of the section in here, you can go back to cut levels and use the midpoint snap and go snap to the midpoint of the line right there. So that's the midpoint, mid-plane of the part. And now you can click on generate, and that's how far the tool would be able to go back on the sides to cut it. So it's computing the toolpath for the reroofing operation. And there it is. Now you can see that if there is a collision, it'll mark those areas in here. So you can see that the holder is colliding. Right, so if you want to avoid the collision and not cut all the way over on the bottom, you can define a boundary for containing your toolpaths. So you can basically have a containment region in here, so you don't go all the way down to the bottom, or you can restrict it along in how far back you're trying to cut. Okay?
Okay.
So, or you can basically program it from additional sides, so you're limiting the toolpath. So in here, going back to this operation, you can change the containments. So let's go back, and also let me enable the multi-threading manager, so each toolpath that you generate will get processed or generated in a different thread. And here I'm going to go back and edit this operation. In the cut levels, I'm going to set the containment to be right up to this point right in here, so not cut past that. So that way there is no collision of the holder with the part and the stock material. So we're now computing the toolpath from one of the sides orientation. And we can repeat the same process for the other side as well. Okay, there it is. There's your roughing, and there it is. Now let's go back and repeat the same for the other side in here. So we could make a copy and a paste of this operation. Right click copy, right click and paste. And now we need to change the orientation. We'll change the orientation, so we'll rotate it 180 degrees about the y-axis. You can now see that the coordinate system is rotated. I'll hide the display of the world coordinates, and now I can repeat the same operation in here. If you take a look at the cut levels, you see that the clearance plane and also the bottom containment planes are in the same orientation as the rotated coordinate system. And now we can click generate, and this would automatically compute the toolpath from this specific orientation. So this is called indexed 5-axis, or also known as 3+2 machining, or positional 5-axis, where you're locking the tool axis to a given orientation. The orientation could be defined by a plane, or you can select the orientation to be normal to a surface to establish that. And there it is. Now you would want to go ahead and program from the front and the back sections to relieve these material out, so you can repeat the same process in here. So I could right click on this operation, select copy, right click on it again, and then select paste. And now I can go back and rotate the coordinate system about the y-axis, so that you can change the orientation of the z-axis to be normal to this particular face. And now I can edit this operation out, and then in the cut levels tab I can specify how far back I would like to go, and I can use the pick option in here to go back and restrict it to a certain area right there, and select generate. So this is how easily you could program roughing operations from different orientations, and then when you post-process, this would all be just one piece of code. And everything is referenced based off this origin that you established initially from the world coordinate system, so you don't have to go back and re-zero it. So all you need is program it from different orientations. So once we have this program, we will then go ahead and run a finishing toolpath. And we can also finish off these pockets and machine the surface face. Okay, so there it is. There's your roughing as you see it right there. Okay? And then finally the last step is to basically rough it out from the back of the part. So we'll make a copy of this and paste the setup. Then we'll change the orientation 180 degrees about the y-axis. Now we'll go back in here, go to cut levels, and we can set the containment to only go back right up to this point, and then generate it. So this would give you a roughing toolpath for the back. You'll notice that in each of these roughing we did a re-roughing operation, so it takes into account the stock that's being left from the previous step. So you're not cutting air and you're saving machining time.
So also, can I do surface plane? I mean, a flat plane on the top of the mold. I mean, instead of doing rough. You know what I'm saying? Like, instead of doing roughing on the top, I'm trying to do like a just plane.
Absolutely.
Flat.
Absolutely. I'm going to show that to you here in just a moment.
Okay.
And there it is.